Today we're going to do a Tukey-Kramer example, which is comparing differences from an ANOVA problem when you have rejected the null. Let's just back up a little bit. We do an ANOVA problem to compare the difference in 3 or more means. Now you may have watched the previous video where I went through an entire ANOVA problem, and actually we're going to do the same study but just now complete the ANOVA analysis. But if you haven't watched the previous one, very briefly, again, we are looking at this when we have done an ANOVA problem comparing 3 or more means. If we reject the null that says all means are equal, we then have to do a Tukey-Kramer analysis to see exactly what those differences are. So let me give you a moment, please, to look at the PowerPoint example. Again, it's the same one we've done with ANOVA. More and more tooth products have a whitening component, and we see that when we go to the aisle at Walmart. Consumer Inc. conducted a survey of 4 different tooth products. 40 volunteers, 10 per product, were asked to use the assigned product for 1 month. On a scale of 0 to 100, with 100 being the best, each was asked to rate how much whiter his or her teeth appeared to be at the end of the month. An ANOVA analysis has found that there is evidence of a difference in mean perceived whitening among the 4 products. Use a Tukey-Kramer analysis to determine these differences. The next slide is going to show our ANOVA results, but I'll give you just a moment to look at the narrative again. Okay, here are our results from the ANOVA analysis. You're going to need several numbers off of this, so I am going to go back and forth. But this is the way Excel does give us ANOVA results. It gives us the summary count up at the top, and we will need some of those numbers. And then it also gives us an actual ANOVA table. So let's see how we would do a Tukey-Kramer analysis of the mean differences. And again, I'll come back to these numbers so you can see where they come from as I'm doing the analysis. In Tukey-Kramer, there are basically 2 things you have to calculate, and then you compare your results. The first thing we calculate is the critical range. Let me give you that formula. CR for critical range. We use a value called Q, which is a statistical value from the standardized range Q table in your statistical tables. It has degrees of freedom C and N minus C. So I'll just put that here for clarity. Times the square root of MSW divided by 2 times 1 over the sample size of the first group you're comparing, we'll call it N sub j, plus 1 over the sample size of the second group you're comparing. Now, think back to our narrative and try to decide what you believe C and N to be. Overall N with no subscript and individual sample size N as well. C, remember, is the number of treatments. So we are comparing 4 different products. We are doing a simplified version, so for us, each of our individual sample sizes is 10. So we're going to have the values 10 under our radical sign because those subscripted n's refer to individual sample sizes. So both N sub j and the one comparing it to, N sub j prime, are all equal to 10. We're only doing that size problem. Overall, we have 40 observations. 4 treatments times 10 each is 40. So let's look up our value for Q. Now, the Q degrees of freedom are slightly different than the F degrees of freedom you used in the ANOVA analysis itself. And Q is a different table from F in your set of tables. So don't look for your F table. You will look for your standardized range Q table. For Q, the degrees of freedom for the numerator or C, as we're showing over here in the formula itself. So C, which equals 4, a little bit different than the F degrees of freedom from the ANOVA problem. The denominator degrees of freedom is equal to N minus C, or 40 minus 4 equals 36. We're going to use an alpha of 0.05 in this problem. You would always use the same alpha you had done in the ANOVA analysis. This is really an extension of ANOVA. So I want you to then look for your studentized range Q table, and you would like to have degrees of freedom 4 and 36. In the table I'm using, we didn't have that. We have to use the closest one, and I came up with a Q of 3.79. That is from using the degrees of freedom 4 and 40, because that was the closest I could get on my table. And we're actually, this problem, going to stick with that because we're not going to use Excel at all to get a more accurate value. It's very, very close. It shouldn't make much difference in your problem at all. All right, so now we're ready to calculate our critical range. Q is 3.79. Now, let me give you a moment as I go back to Excel for you to decide what you believe MSW to be. Take a minute and look at your ANOVA table. Can everybody agree that MSW, mean square within groups, is 0.10 if you round it. 149.1 if you round it. We always divide that by 2. And in this problem, we are only comparing groups of size 10 each. So we have 1 over 10 plus 1 over 10. Let me briefly tell you how you would handle things differently. Say, for example, you had one group of size 10, another group of size 10, another group of size 12, another group of size 12. If that were the case, when you were comparing the two groups of each size 10, you would calculate 1 over 10 plus 1 over 10. But when you were comparing a group of size 10 to one with size 12, you would actually have a slightly different critical range because sample size matters in terms of critical range. So you would have in that comparison 1 over 10 plus 1 over 12. We don't have to worry about that in this problem. We get a critical range to be 14.63, completing the mathematics of that equation. Here's what the critical range is telling you. The critical range is saying, just due to randomness, when we collect our sample for product number 1, maybe some type of a gel toothpaste, to product number 2, maybe some type of whitening strips, even if they whiten equally, just due to randomness among people, we'll have some different values. So, how much difference in our averages from group 1 to group 2 is reasonable due to chance, and how much difference is too much to be reasonably due to chance? The critical range is our cutoff, 14.63. So, in other words, when we compare group 1 to group 2, if that difference is more than 14.63, we can say statistically with confidence there really is a difference in the whitening of group 1 versus group 2. On the other hand, if we come up with a difference less than or equal to 14.63, yes, there was some difference in terms of randomness, but not enough to say there was a statistical difference. That's what the critical range means. Next, what we have to do is actually make every possible comparison. And let me go to Excel one more time and show you we're going to be comparing means. And let's take a moment and see if you can tell me where are the means in this data? Well, another word for mean is average. So if you will look on the summary table, there are the 4 means or averages. In other words, on average, the 10 people who used product 1 rated the improvement in their teeth being whiter by a 42.5. That's the column we'll be using. That's the average column. So we actually have to list every possible mean difference. And we want their absolute value because we're just going to compare mean of group 1 to group 2 one time. So we just want to know the absolute value difference. Okay, I'm not going to flip back and forth to the table over and over, but group 1 had a mean of 42.5. Group 2 had a mean of 40.5. Again, absolute value differences for an overall difference of 2.0. Now, let's compare it back to that critical range. Yes, there was a little bit of difference between group 1 and 2, but it was so minor it could be reasonably due to chance. So I'm just going to kind of jot off to the side here. There is no statistical difference in those two. Next, let's compare group 1 to group 3. It was 42.5 minus 62.0. That was a much larger difference. There was an average rating of 19.5 points difference, more than our critical range. So let's just kind of jot off to the side here. You know what? There is statistically a difference in group 1 versus 3. I'm going to make a little bit more room on my page here. Next, group 1 to group 4. Just be very methodical, very careful that you list every possible pair. 42.5 minus 59.5. And if you need to, you can stop and rewind this video and see where these numbers come from. I'll show you at the end one more time, but I want to make sure you know where I'm getting these X bars. The mean of group 1, the mean of group 4. For a difference of 17. Hey, that was significant. More than our 14.63. Now that has taken care of every possible pair involving group 1. So now let's go to what's left for group 2. We don't have to compare groups 1 and 2 again because we did their absolute value difference. We need X bar 2 to X bar 3. Again, absolute values. A difference of 21.8. Hope everybody agrees. Wow, that difference is significant. Now let's compare X bar 2 to X bar 4. We haven't done that one yet. Another significant difference. Okay, the only pair left we've not looked at involves X3 and X4. We've done everything involving group 1, everything involving group 2. We took care of several of ours involving groups 3 and 4 with 1 and 2, but now we have left X bar 3 minus X bar 4. Pretty small difference of those two products. A little bit, but certainly an amount that could be due to randomness. So statistically, no difference. One more time, let me scroll up again. We got our critical range to tell us how much difference was reasonable due to chance or not. Any value less than or equal to 14.63 is not a statistically significant difference at alpha 0.05. Anything larger than that is. So now we've made all our comparisons to see pair by pair where those differences lie. The final step is going to be to put these paired differences together and come up with a managerial conclusion. Before we do that, let's go to Excel one more time. Make sure you see, again, where these numbers came from. And it's right here with these averages. All right, let's come up with some type of conclusion. I want you to use the format of statements and actions like we've used in our hypothesis test as well. Your statement really needs to discuss all of these pairs of differences, all 6 of them. So let me scroll up just a little bit so we can see them all. Now, I won't have room, I'm sure. We'll have to scroll down in a minute. But we want our statement to come up with a discussion of all 6 pairs, and then finally a recommendation to consumers of which products to use if you're interested in your teeth being whiter. Let's start at the top. There is no significant difference in whitening between products 1 and 2. Okay, that really took care of discussing that pair. Now you can actually do 6 statements here, and boy, I would never complain with that. It's certainly fine for more detail. But if you want to, if there are some logical pair differences that go together, then you can combine a little bit. And so what I did was kind of look down and I saw, do you know what? 1 and 3 had a difference and 1 and 4 had a difference. I'm going to look at these 2 together. Now is the time to stop back and look and say not just a difference, but which was better. So now we have to look at the individual values. Now remember, in this problem, a big number is better because we said on a scale of 0 to 100, with 100 being best. You think your teeth are whiter. It could be that another problem, a small number is best. If you were doing rates of errors, a small number would be best. So in this problem, a big number is better. Let's look at 1 versus 3. The average for group 3 was 62 compared to only 42.5 for group 1. So 3 was definitely better at whitening than 1. Likewise, 4 had an average rating of 59.5. It was also better. So I'm going to compare both of those at the same time. I'm going to combine it into one sentence, but certainly 6 separate sentences is great. There's absolutely nothing wrong. But here's what I'm going to say. Products 3 and 4 are both better whiteners than 1. Now please don't combine too much together. Let me know that you sought out and looked at the Tukey-Kramer pair analysis. But I felt like that was a good logical combination for those 2. So that again, we've taken care of that, we've taken care of that. Let's look at these 2 together because they both involve group 2 to 3 and group 2 to 4. We have to look at individual values again. Big numbers are better. And look, in both cases, product 2 had a significantly different score, a significantly lower score than product 3 or 4. So we can write something similar to combine the next 2 pairs. Products 3 and 4 are both better whiteners than 2. Please do not try to combine all 4 of those middle pairs into one sentence. Again, certainly more is better than less. Please keep that in mind. All right, we get down to the final pair. And we see that statistically there is no difference in products 3 and 4. Okay, I'm calling all of this a statement or statements, I should say, of the pair difference results we found. Now we need our recommendation or our action. So let's look back at these statements. 1 and 2, no difference. Hey, 3 and 4 are both better than 1. 3 and 4 are both better than 2. But between 3 and 4, no significant difference. So in this case, we would say that consumers should choose between products 3 and 4. Again, based on the factors such as taste, such as the type of product, if you like a strip better than a gel or a mouthwash. In terms of whitening, though, we have seen 3 and 4. We should choose between 3 and 4 for whiter teeth. Now, this is using Tukey-Kramer and using the statistical concept of randomness in our samples to make our conclusion. Here's what I do not want you to do. Do not now look at 3 and 4. Let me go to Excel one more time. Do not go to 3 and 4 and say, hey, product 3 was just a little bit better than product 4. Don't do that. We have said statistically there's no difference. Yes, in this small sample, 3 rated to 62 on average and 4 rated to 59.5 on average. But that difference is statistically insignificant. So stop where I stopped. Stop with either one is giving us an equivalent whitening, or at least there's no evidence that there is a difference between the two. That's the purpose for doing this statistical range to start with. That's why we came up with the with the critical range of 14.63 to say, here is our cutoff in terms of statistical significance. So, show me the pairwise comparisons, give me good statements of what it means, give me a final recommendation. Then do not go beyond Tukey-Kramer and say, but wait a minute, 4 was a little bit better than 3. That's not using our laws of probability, our laws of statistics to come up with a conclusion.